Hi, Assalamualaikum. My name Muhammad Uzaifiras, and this my teammate Satya Warren, Alif, and me. My topic: analysis of Campus Alam Pauh Putra network with Wireshark. Introduction: monitor network traffic in real time. Identify performance issue. Optimize network efficiency. First, general network traffic analysis. Identifies network. Help detect congestion, latency issue, and bandwidth limitation that affect network performance. Enhance security monitoring. Detect usual traffic patterns, potential cyber threat, and unauthorized access to the network.
In this video, I will perform a general network traffic analysis using Wireshark while connected to my university Wi-Fi, Unimap campus Wi-Fi. Let's get started. First, I open Wireshark and select the network interface I am using, which is Wi-Fi. I start the capture and let it run for a while to monitor network traffic. Now I open Unimap portal and let it fully load. Next, I open YouTube and play a video. Okay, now the video is running. Then I navigate to another Unimap web page. As expected, the number of packets captured has increased significantly, now exceeding 20,000 plus. Now let's apply some filter to analyze specific traffic. Outgoing traffic shows all destination my laptop is communicating with. At here you guys can see that source is my laptop IP address and the destination is in the difference. Now let's display all source communicating with my laptop to search incoming traffic. Next, we search for TCP traffic. In this filter, we filters and analyzes transport layer traffic.
Next, latency and packet loss analysis. Latency analysis measure the delay in data transmission, which affect network speed and responsiveness. Second, high latency can cause slow loading time and poor communication. Next, packet loss analysis. Detect missing data, packet that cause delay and connection issue. Next, high packet loss affect network stability and performance. Next, I share the video.
I will analyze network latency and packet loss using Wireshark and the ping command. I open Wireshark and select my Wi-Fi network to start monitoring packet. Now I open the command prompt and run the following command. This sends 20 packets to Google server to measure response times. To analyze this, I applied the filter ICMP in Wireshark. This filter helps us focus on ICMP request and response packets, which are used for the ping test. Now we can see both request and reply packet appearing in Wireshark. Let's analyze the ping result. Packet sends 20, receive 20, loss 0, which means 0% loss. Latency minimum 11 millisecond, maximum 24 millisecond, and average 30 milliseconds. This shows that my Wi-Fi connection is stable with minimal latency and no packet loss. By using Wireshark and the ping command, we can measure latency and packet loss, which are key indicators of network performance.
Next, bandwidth usage analysis. Measure network capacity usage. Analyze how much bandwidth is being used by device and application. Second, identify high bandwidth consumer. Detect user or application that consume excessive bandwidth, helping to prevent congestion. Next, I will share the video.
In this video, I will analyze bandwidth usage using Wireshark and Task Manager. I restart Wireshark and begin capturing packets. I reopen some websites and reload it, and playing a YouTube video again. Now the packets are above 1000 and I capture these packets. Now I open the saved packets. To focus on my device traffic, I apply the filter. This shows my device traffic. Now I open statistic menu and select IO graph to visualize network usage over time. Here we see a graph showing the volume of packet and any TCP error occurring. To identify which processes are consuming the most bandwidth, I open Task Manager and check the Network tab. Now these are the processes consuming the most bandwidth. Using Wireshark and Task Manager together provides insight into bandwidth usage and help identify applications that consume high amount of data.
Finally, the NS response time analysis. This analysis focuses on two key aspects. First, Measure the DNS query speed. This analyzes the time taken for a DNS request to resolve a domain name to an IP address. Second, identify slow DNS performance. It detects delay in DNS response that can cause slow website loading and network disruption. For the conclusion, through these 4 tests, we successfully analyzed general traffic, latency, bandwidth usage, and DNS performance using Wireshark. This helped in understanding network behavior and troubleshooting issues. That's all from our group. Thank you.